Hello everyone. As part of core Python training, we will start with introduction, features, installation on Windows, setting of path, working with Python, executing a Python sample Python script, and differences between Python 2x and 3x, reserved keywords, operator, bitwise, and miscellaneous examples or problems. Let's start with introduction. Introduction. Python is an easy to learn and powerful programming language. It was developed by Guido van Rossum. He is the chief architect of Python programming. Object-oriented programming is a lot easier than in other languages like Java. Python is both an interpreted as well as compiled programming language. Python code is translated into intermediate code which has to be executed by a virtual machine known as PVM, a bit like a JVM in Java. Python's elegant syntax and dynamic typing makes it ideal for scripting, application, as well as development. Features of Python. Python is a free and open source. Python is a high-level programming language, easy to learn and easy to code as well. Coming to portability. Portability. If you write a Python code for Windows machine, you can run it on Mac, Linux, and in any architecture. In other words, we can take one code and run it on any machine. Python is an interpreted programming language. If you are familiar with languages like C++ or Java, you must have compiled first and then run it. But in Python, there is no need to compile. Internally, its source code is converted into intermediate form called bytecode. So all we need to do is run your Python code without worrying about linking libraries and other few other things. Python is an object-oriented programming language. Everything is an object in Python. Even a function is an object. Even a data type is also an object in Python. There is also a wide and active development community going on in Stack Overflow as well as in Google Forums. Extensive libraries. There are many libraries for browsers, unit testing, document generation, databases, threading, CGI, email generation, as well as image manipulations, as well as scientific computing. Now coming to extensible. Python is an extensible programming language. You can write some part of Python code in other programming languages like C, C++, or even Java. Python is embeddable. We can put code in other languages in our Python source code, or we can also call another source code in different written in different languages like C++, Java. We can also call a jar file from Python code. This allows us to integrate scripting capabilities into our program of other language. Coming to career opportunities. Career opportunities we have in Python are data scientist, big data, deep learning, machine learning, AI for web developers. We'll go with Flask, Django, system engineers, as well as test engineers or sysadmins. Python is a dynamically typed programming language. Unlike other language, we don't have to specify any type of a variable. Dynamically typed. It takes the value of a variable at runtime, not in advance. Apart from these pros, there are also some cons in Python. Python sometimes might run slow, and also database DB access layer is undercooked in Python, not like JDBC where it is extensively used in some higher enterprises and all. Coming to Python applications. When it comes to web development, Flask for the microservices, Django for the single page applications or multi-page applications. Web framework. Also Pyramid. Request for the HTTP library. Beautiful Soup for the HTML parsing. For the Paramiko for the SSH protocol. Twisted Python under the license of MIT for the asynchronous network programming. Also coming to flavors of Python. CPython is the C implementation of Python. Similarly, Jython. Jython is a Java implementation running on JVM. IronPython. It runs on .NET Framework. RubyPython, which is an Ruby implementation of Python. PyPy. It makes Python faster. Coming to file extensions in Python. .py is a Python scripts, normal Python scripts. .pyc is the compiled Python scripts. Usually it generates when you compile a Python script. .pyd is a Windows DLL file. Dynamic linked libraries. .pyo is a file optimized. With optimizations. .pyw, a Python script for Windows. When it comes to science and numeric applications, Python plays a very prominent role. Extensively used libraries are SciPy, used for scientific computing. NumPy, used for number computing. Pandas, used for data analysis. Python also plays a major role in machine learning, artificial intelligence, as well as in deep learning. Coming to next subtopic, installation in Windows. By default, Python comes with inbuilt in in Linux as well as in Mac. But in Windows, we have to install explicitly. To install Python in Windows, go to the official python.org, go to downloads and install the latest version for Windows. Click here to download. I've already downloaded, so I will skip this part. You will get this .msi file. If you double click this file, you can run. I have already installed, so these things in your case it will be different. You can go ahead and do the default next. After installing Python, come to the Windows and type Python. You can see here one IDLE and Python command line. You can choose either of them to do your programming with interactive shell, or else you can also go with the command prompt. Open the command prompt, just give Python and enter. Python interactive shell opens. If it did not open, go to the path where you have installed Python. Suppose I have installed Python at C Python 37. Take this path, copy this path, go to C drive, go to properties, my computer properties, advanced system settings, environment variables, edit, copy and OK. I have already set this path, so I'm not doing this now. In your case, you have to give OK and OK here and apply. You should also set path for the scripts. Next 7 scripts where your pip is installed. Go to computer properties, advanced system settings, environment variables, edit, paste. OK. So now your pip works. Now go to the command line and type Python. You can see the interactive shell here. Just do Ctrl Z or exit. Parentheses will come out of the interactive shell. You can give pip. Pip is not recognized as internal or external command because I haven't set scripts path in my environment variables. So go to the script path, copy, go to my computer properties, advanced system settings, env variables, edit, paste. OK. Okay. Okay. Just restart the command line again. Windows R. Say pip. Now you can see here pip. You can do pip install any number of packages. Pip install say Flask. Flask installs from PIPY package libraries. Coming to another subtopic, working with Python or executing a first Python script. Working with Python, you can either choose Python IDLE from like type Python. You can see a Python IDLE, or even you can choose Python command prompt, Windows command prompt. By giving type Python, Interactive Shell opens in a Windows command prompt. Let's open an interactive Python shell. You can use Python shell as a calculator. 2 plus 3 gives me 5. You can also use Python interactive shell as REPL. Print welcome to Python training. Print, you can see name print is not defined. Here P is small. Print you can also do division Python 1 by 3. Here you can see 1 by 3 gives me 0.333333 and so on, because it's Python shell 3.7. In case of Python 2.7, 1 by 3 gives me 0. Let's try to execute a Python script. You can execute a Python script using IDLE of your choice. I suggest you to use PyCharm or even Eclipse or even Visual Studio Code or even Sublime Text. Say print welcome to Python training. Always save this file with .py extension. hello.py. How do you run this Python hello.py file? Go to the command prompt, go to the path where you have saved the file. Give Python space the file name hello.py, enter. You can see here welcome to Python training on the command prompt. Coming to the next subtopic, difference between Python 2x and 3x. I have both versions of Python. I have Python version 3.7 and also Python version 2.7. Coming to the first difference, division in Python 3x. Say print (3 divided by 5). You can see here by default division is returns me a float in Python 3.x. When it comes to Python 2.7, Python print 3 divided by 5. It says 0. By default, we are not getting a float value in Python 2.7. Similarly, another difference in Python 3x and 2x is print function. Print function by default takes the parameter in 3x, say hello. But in case of Python 2.7, print hello. Parenthesis is not mandatory. But if you try the same thing in Python 3x, you will get an error. Missing parenthesis in call to print. Similarly, also in Python 2x, we used to have a sequence type called xrange. Xrange of 5 gives me a list. For I in xrange of 5. Print I. You can see here we got a iterator starting from 0, 1, 2, 3, 4. But in case of Python 3x, we don't have that xrange. Xrange has been modified to range. It throws me an error saying no xrange. You can see here name error, name xrange is not defined. And one more thing is error handling. Error handling we'll also discuss in detail in coming Python sessions. In Python 3x, in an error handling, print parenthesis is mandatory. Except name error, comma error. You can see here it says invalid syntax in Python version 3.x, but in Python 2.7 it's a valid. See, if you can see here the entire try catch block is valid, so we get an output like high. So in case of Python 3.x, try block is same, print we'll try to raise an name error here. Try high. But in except block we have to mention as keyword. Name, error, as. Print inside error. You can see here this entire statement is valid in Python 3x because of this as keyword. We'll discuss in detail in coming sessions of try exceptions, exception handling, as well as raise exceptions and everything. One more key difference in Python 3x and 2x is input function. Say my input is equal to input, take a number, enter a number. In Python 3x, as you know, input function by default gives me a string, say 24, type of my input gives me a string, whereas in Python 2x my input is equal to input of enter a number. Say 24, type of my input gives me an integer. Here input has been evaluated in Python 2x. You can see here it's of type int. In Python 2x, input function returns the evaluated thing from the user, more like equivalent to eval. Input enter a number. This is equivalent in Python 3x. Python 2x and Python 3x. Input function is equivalent to eval of input function. Raw input is equivalent to input in Python 3x. And one more difference in Python 2x and 3x is Python 3x returns iterable objects instead of lists. Say range of 5 gives me iterable object, while in case of Python 2x, range of 5 gives me a list. You can see here it returned me a list. This is one of the difference in Python 2. Coming to next subtopic, keywords, wizard keywords, operators and bitwise operators. What are the keywords in Python? These are the Reserved keywords in Python. Coming to identifiers. Naming conventions of these identifiers are, it can be alphabetical symbols, either uppercase or lowercase, alphabets, either uppercase or lowercase, can start with underscore, if it starts with underscore, it's a private variable. Just for your information, identifier should not start with a digit. Identifiers are case sensitive. And dollar is not allowed in Python. Identifier namespace is not allowed for the naming conventions. Let's check whether these are valid Python identifiers or not. Suppose an identifier starts with a digit, say 4443 or 44 test. Not valid. Say total, valid, because it starts with alphabets. Valid. Not valid. It's a valid because it starts with an underscore. Not valid because it's a reserved keyword. Not valid. Python 3 is a valid identifier. All is not valid. And coming to operators, there are as many as 7 categories of operators in Python. Arithmetic operators, relational operator, assignment operator, logical operator, membership operator, identity operator, and bitwise operator. We'll certainly go to some examples of arithmetic operators. 3 plus 2, 5. Plus is an arithmetic operator. Similarly, 3 divided by 2 gives me 1 point something, 1.5. Similarly, 4 divided by 5 gives me 0.8. Coming to relational operator. Relational operator always gives me a boolean. Say 5 less than 4 says false. 5 greater than 4 says true. And also assignment operator. Assignment operator, say take a variable called a is equal to 5. Here is equal to acts like an assignment operator. If you try to print this variable a, it gives me 5, where 5 has been assigned to a variable called a here. To arithmetic operators, plus, comma, minus, comma, divide, comma, multiplication, comma, modulus, comma. Coming to relational operators, less than, greater than, less than or equal to, greater than or equal to, and so on. Coming to assignment operator, is equal to. There are also some other assignment operators like plus is equal to, comma, minus is equal to, comma, star is equal to. Let's take some examples. So like a is equal to plus is equal to 5. Here you can see if you print a gives me a 10. Print I have assigned a is equal to star is equal to 10, gives me 100. Print a. These are some assignment operators in Python. Coming to another operator, logical operator. And comma or comma ampersand comma type comma not. Let's take some examples. A is equal to 7 greater than 7 and is a logical operator here. 2 greater than -1. It should return false. Print it returned me a false. Similarly, a is equal to out of 0 should it be true. Print a. Coming to membership operator. Membership operator in Python is in. Coming to membership operator. Membership operator checks whether a value is in a sequence or not. Sequence in a sense, list, string, tuple. We'll discuss in detail about these sequence types and data structures. Let's have some example like 1, 1 in, comma 2, comma 3, comma 4. It returns me true. Say check whether 5 in list 1, comma 2, comma 3, comma 4, comma 4. It should return me a false. This is the membership operator. We also have membership operator like not in. Coming to identity operator. Identity operators are is, comma, is not. Let's open a fresh shell. Whether 2 is 20, it should return me false. Whether 3 is not 30, should return me a true. Coming to bitwise operators. Bitwise operators are ampersand, comma, pipe, comma, cap, tilde, left shift and right shift operators. Coming to some examples of bitwise operators. Say 2 and 1 give me 0. Just take bin of 2 will return me a binary of 10. Similarly, bin of 3, bin of 1 should give me 1. If you do logical AND for this, it's return me a 0. Two and 3 return me a 2. Bin of 3 give me 11. If you do logical AND 0 1 give me 0 1 1 1, so it's binary of a 2. If you do 2 or 1, it's return me 3. If you do logical OR of binary of 2 and 3, 0 1 1 1 1 1, so it's logical 3. Similarly, you can also do XOR of 2 cap 3, it returns me 1. You can also right shift and left shift 2, left shift 2 give me 8. So if you shift this binary to 2 bits left side, it will return me a binary of 8. 2 right shift to 2 gives me a 0. Binary of 2 right shift to 2 bits gives me 0 here. And this is all about operators in Python.